Hey guys, so today we have this question. We have a hotel with 100 rooms, guest reserve a room and pay in advance. Room are held for guests until 10. After that time, if the guest does not show up, the reservation is cancelled, the hotel keeps the payment and may rent the room to walk-in guests who arrive without reservation. So we have the probability of someone to arrive, which is 19 divided by 20, which is 0.95. Okay. And now they ask us, and they tell us there's 104 reservation for tomorrow. Okay. So now we're required, let X be the number of guests with reservation who arrived by 10 tomorrow. What is the distribution of X? Okay, and we know that the arrival of someone is not dependent on another person. So X is a binomial distributed with P of 0.95 and N of 104. Now they ask us, what is the probability that there won't be enough rooms for the guests who arrive by 10? So this is also easy to do. We calculate what is the probability of X being bigger than 100, meaning the probability of either of them happening. And because they are independent and exclusive, we can just add them. So the probability of 101, 102, 103, and 104. So this is the sum, starting with I equal to 101 up to I equal 104 of n choose I, and then the probability of I successes and the complete probability, which is 0.05 of n minus 1 fails. And this is around, and I put it in a calculator. If you want, I can also link the calculator to 0.2308. Now they ask us, given that we have a fine if someone arrives and the room is already booked, what is the optimal number of room to reserve? Okay, so now we assume that the walking guest arrive and guests pay $80 per reservation. If the guest arrives and there is no available room because of overbooking, they receive a refund of $80 plus 1.6 it's supposed to do. So 80 times 1.6. I see translate the question did not happen when. Also assume that the demand for the reservation is unlimited. The hotel management wants to set the limit on how many rooms it can reserve in advance. So what I did here was to solve using Python. So we have 5,000 repetitions, and we want for each one to see how many between 100 and 120 rooms will be the optimal number. So why we stop at 120? Just a guess, but we assume there is some kind of max point that above it we will see diminishing, and before it we will see increasing. So if we see that the limit is 120, we will increase the limit to be, for example, 130 up until we see some kind of maximum. Okay, so this is to get the how many people are arriving with X, P, and the amount of reservations. Now we want to see how many times how many times people we have overbooked, and then we want to see what is our profits, and after we get our profits we printed it. Okay, so if you want also add an image of the simulation results, so 1 second I will do it also, and we can see that the top will be 106. Okay, 3, 2, 1. Okay, so we see that the top is here in 106. So this is the top, and we can see that before it's a little bit lower, after it's a little bit lower. So this is the maximum. Easy to do. Guys, please share this video. It will help me a lot. And thanks, and until next time, I'm out.